All right, hey, we're going to find the focus for these problems right here. First off, I'm going to kind of put up here my nice little chart. I don't know if I can see that well enough. Maybe not. It's kind of hard to get it into this focus here. That's one for parabolas. Here's another part of parabolas. There's an ellipse. There's the other part of the ellipse with some of the formulas. Right, as we're looking through that. And I'm going to kind of talk about this right here. Don't worry about this here if you don't get it. I'm going to write them up on the board here anyway. So to find the foci of the equation, first off I want to do this here. I want to get this with the x squared, in a sense, by itself with a positive value. Because here's what I'm going to do. So I'm going to basically, technically multiply everything by -1. And when I do that, I have x squared equals -y. And that's real important. I can tell the center here of this particular circle is at 0, 0 because there's no values to really be added or anything. And all I have to do is this. My big formula is this. So it's when x squared equals 4py. Well, basically, x squareds are the same. Y's are the same. This is the same thing as a -1y. So basically, 4p equals -1 divided by 4. So p is -1/4. And the reason that's important is p is the distance from the center of the circle to our foci. So if I was to graph this one, I know the vertex is right here. I know this is one that goes up and down. And so the foci is going to be at this point right here, 0, basically. And I'm going to take the center 0, 0 and add -1/4 to it. So that puts me at the point 0, -1/4. There's the focus for this particular parabola right there. And on parabolas, basically 4p. So whenever I have it in this form right here, all I really do is dividing by 4. I take -1 and divide it by 4. And if I use that shortcut right here, the same thing's true here. This one's a y squared equals 4px. Well, notice, that's 3 right above it. Y squared equals 3x. So basically, 4p equals 3 divided by 4. P is 3/4. So this particular graph, now I am going to say this here. I know this is a y squared. It's going to look like that with the center at 0, 0. So this 3/4 has got to move along the x-axis right there. So it's going to be 3/4, 0. I've got to add 3/4 to the x, or wherever that center was. So this point here is 3/4, 0. Because all we're doing is this 4p, find p, which is that number divided by 4, if we're in this format right here, makes it really, really easy. And I have found the focus of those two parabolas. Now, to find the focus of the equation here for the ellipse, I'm going to kind of do somewhat the same. First off, let's look at this here. I'm going to look at my center. My center is at the point -3, 2. That's always helpful. Okay? And this is what I know. This is my a value. A is always the larger one with the ellipse. So a squared is 16. Square root that, a is 4. All right? This is my b squared. So square root, basically 12. This is square root 12, or 2 square roots of 3 is what b is equal to. But to be truthful, to find my c squared is this. It's the a squared minus the b squared. Well, I could square these back, or basically, that's a squared right there. So c squared is 16 minus 12. So that means c squared is 4. And so what's the square root of 4? 2. So I'm going to have a focus. It's going to be what? Plus or minus 2. Now here's what I also need to know, because this a is larger. I know this is a vertical. So if I go over here, 1, 2, 3, and up 2, and put a dot, I know the vertical is the a from right there. That was the point -3, 2. This one goes up 4 more. My vertex, and horizontally it's 2 square roots of 3. It's going to look more something like this right here. Is what this graph's going to look like, something like this here. So this plus or minus 2 is 2 from the center up. So basically, I was at 3, 2, and I've got to, one time I find the foci, I've got to add 2 to that 2, and the other time I got to minus 2 to that 2. So that means my foci are going to be at, one time when I do add the 2, it'll be negative 3, 4, because 2 plus 2 is 4, and it will also be at negative 3, 0. So my foci is negative 3, 4, and negative 3, 0 for that particular foci. And now then for the ellipse, kind of works a little bit. What I need to have is this here. This is what I know. Okay? The A is always first on these here. I know the center of this one is at 0, 0, because there's nothing being added or subtracted here. I also know this here. My A value is A squared is 9, so that means A is equal to 3, and this is B squared, so B is equal to 5. And C squared is the largest of the numbers on the hyperbola, because on a hyperbola, I'm kind of graphing this as a quick little deal. If there's my center right here, I know this is going to be a y squared deal, something looking like this here. Don't necessarily know where all the points are just yet, but I know this here. The focus is out here. This is C. Here to here is A. Well, we just know that's got to be 3 to right there. That makes it negative 3 to right here, on that point right there. So what I also know is this. Okay, if A is 3, C squared is equal to the A squared plus the B squared. So basically, as a shortcut, A squared is 9, B squared is 25. So C squared is 9 plus 25. Well, what's 9 plus 25? It's 34. So then C is just simply plus or minus the square root of 34. And I know this is on the x-axis. So basically, from here to here, the distance is square root of 34. And here to here, to this focus, it's negative square root of 34. So, now I'll let you get away with this. Plus or minus the square root of 34, because it's along the x-axis. Comma 0 are my foci. Or for those that are a little more specific, you could write the square root of 34, comma 0, negative square root of 34, comma 0. I have now found the foci of the distance. And basically, in all your problems, A is the distance from the center to the vertex, the center to the vertex, vertices here, and the focus, C, is the distance from the center to the focus, center to the focus, whether it's an ellipse or a hyperbola. That will help you out. And on the regular parabolas, you find the P.